Hello, everyone, and welcome to today's Bytesize talk. I'm extremely happy to have with us today Alex Peltzer from Boehringer Ingelheim, and he is a very long member of the nfcore community and also a former core member and one of the founders of nfcore. Today, he's going to talk about version 2.4 of the small RNA-seq pipeline in nfcore, which has been released about 4 months ago, I believe. So
Yeah.
off to you.
Thank you, everybody, for joining in. Please feel free to also raise questions in the chat if you have some. And I'm going to talk a little bit about the small RNA-seq pipeline. For those of you who are a little bit longer with nfcore, there was already a bite-sized talk on the small RNA-seq pipeline a while ago, but there were some substantial updates coming, and I'm going to cover exactly these updates that were actually implemented in the last couple of months with a new release as well. So let me quickly jump through. So the talk today is going to be a little bit more about the tech and less on the biology part. I mean, there are some some points that we also addressed in the biological part of the pipeline, but these are only minor changes that allow a little bit of more flexibility. But the major part this talk is going to be about today is I called it the great overhaul. So the conversion of the pipeline from previous versions to DSL version 2, which was mostly handled by Lorena Pantano and some other colleagues there. And then some important bug fixes and improvements in terms of how the pipeline actually can deal with data in terms of profile-based parameters, some cleanup of local and nfcore modules. And also on top of that, we had a couple of requirements coming from users as well with respect to UMI handling in the pipeline. And I'm going to go a little bit more in detail in the next couple of minutes. So maybe as a quick recap of the nfcore small RNA-seq pipeline, as the name already suggests, the pipeline is actually usable for small non-coding RNA analysis. So functionality actually covers analysis from sequencing outputs until you have basically metrics and also counts for these small RNAs, non-coding RNAs. The functionality overall is pretty much the same as I already briefly mentioned. If you have questions in terms of like the biology, also the introduction on what the pipeline can actually do from that perspective, there's this excellent talk from Lorena Pantano from 2021, which gave a very good introduction into the pipeline and the background that you need to understand for doing small RNA analysis. And I actually put in the link here, but it's also available in the bite-sized talk series already. So on the website of nfcore, you can actually find it very easily. So it's not so far away that you can actually rewatch the video on YouTube. So the improvements that I'm going to talk about today are largely towards the technical stability, not necessarily the functions. So we had a couple of issues coming up more and more, and then we had some updates done, some small fixes done. But in the end, it turned out that there were some substantial restructure components that we needed to do to actually tackle them more effectively. And that's what I'm going to talk about now today. So the so-called great overhaul, I mean, as some of you may have seen, small RNA-seq is quite an old pipeline. So it's one of the older pipelines in the nfcore community. There were a couple of predecessor pipelines, also internal pipelines, for example, here at Boehringer Ingelheim, but also in other companies and institutions. They had smaller pipelines that can cover parts of this small RNA-seq pipeline. So there was a lot of input from a variety of people. So many people actually contributed to the pipeline. However, it also there was periods where a lot of people were active, and then activity in the pipeline actually dropped to zero or almost zero. There was only a few people around, like Lorena, myself, and a few others, trying to tackle issues and bugs. But the end, it also was very difficult for everybody to actually tackle these issues more actively, because people also had their day-to-day jobs and could only focus on these bug fixes in the evening, for example, in some part-time hours that they just had available. So it was not so easy actually to tackle these issues very effectively. We identified a couple of shortcomings with pipeline configuration. For example, we had options and parameters that were handled in not very nfcore style way. We had a lot of local modules when the pipeline was migrated to DSL version 2, because it was a DSL 1 pipeline in the very beginning. And we also had a bit of a technical debt situation, like template merges taken quite a lot of time actually to be done properly. bug fixes in that actually caused more trouble than they actually fixed. So it wasn't always perfect because also some of components of the pipeline were not tested in absolute detail. So we had trouble actually writing proper tests that cover all aspects of the pipeline because we were also lacking proper test data for some of the more exotic protocols that are supported by the pipeline, I would say. And there's a couple of other parts that you can also all read up on if you're interested in one of the tickets that we had for summarizing all of this. So what we started then, that's actually mainly driven by us here at Böhringer Ingelheim, a colleague of mine, Gregor Sturm, who's also very active in the community, and another colleague, Christopher Moore, and myself. We had a couple of people from ZS, Annabella and Nicola mainly, but also others helping out. And we had a meeting with them to discuss, okay, let's bring this pipeline up to speed in terms of quality, in terms of stability. Let's talk about what we can actually add to the pipeline to make it more stable, more reliable, improve documentation, bring it up to the latest standards of the nfcore community. And we then also pulled in Lorena basically and talked to her, what are your plans? Are there things that you think we should be covering? So we basically went into this full-size open source discussion committee meeting, let's say, where we actually then had a project board set up in the nfcore community. Actually, it's not that interesting anymore because in the beginning, this was very active on the more left side, priorities and in progress. But nowadays, as you can see, there's a lot of things that have been done and actually tackled by the team doing the development. Most of this stability improvements were done by Anna and Nicolas, where Gregor and myself and also Lorena gave input and also supervised and helped out wherever we could, together with also other people in the background, like Christopher, basically doing testing, for example. We actually did this out in the open, so with a lot of interaction happening across this project board and with regular team check-ins. So one of the major improvements that I want to highlight, because that was a bit of a bummer for quite some time and was a bit of a pain actually to have this implemented in the formal way. So we had a switch in the pipeline, which was called -- protocol Illumina, which then indirectly set other parameters using functionality, which is called like this params.put if absent, which is kind of Groovy syntax to put in a parameter into that scope. The problem with that was it looks nice. It looks actually quite straightforward. You understand it at least quickly. The problem was it had weird side effects. So we were not 100% sure why this was not always working as it should. There were some side effects if people, for example, overwrote some of these parameters manually, and you set a protocol like that, it caused trouble. People had the feeling like this is not progressed properly through the pipeline to the individual modules. So we had more trouble with this than we had without that and having people set the parameters manually. So for a long time, the workaround was basically we told people, set the parameters yourself. Set clip R1 to 0, set 3' clip R1 to 0, and set your 3' parameter this way. Then you have exactly what you need for Illumina data. That is, of course, from a user perspective, this is not ideal because it's also not very nice because you need to set 3 parameters manually, whereas a profile would handle that. And that's exactly what we then also did. There were a couple of things that we had to change from a strategic level in the pipeline. But in the end, what we actually did, we actually went with proper profiles for default. So protocols are now also available as extra profiles within the pipeline. So the only thing you do basically is if you want to set the defaults for Illumina, small RNA-seq analysis protocols, then you just do profile test, Illumina basically, and then you get exactly what these defaults automatically set for yourself. So that doesn't look like it's a lot of things. That's a lot of changes, but we had a lot of dependencies on this kind of protocol parameter set from the DSL1 version of the pipeline, which then also required changes in modules, changes across the entire pipeline. So it wasn't so straightforward to actually do that entirely in a few hours only. Another big point was so-called UMI handling. The previous pipeline didn't have functionality to actually work with UMI-based protocols. However, there were more and more users actually requesting that. One of the more prominent protocols that people are actually using is from QIAseq, for example, which is UMI-based. So we had to look for options to implement that in the pipeline. The very first way to do that was based on the UMI tools, which turned out to be relatively slow. something that also people in the RNA-seq pipeline found out a while ago, that this can be cumbersome, has weird crashes, and sometimes it's really, really slow. And we then had to benchmark basically, are there alternatives? Are there possible solutions for that? We found another tool, which is also now adopted in the RNA-seq pipeline, which is called UmiCollapse. However, we also had to write a module for that. We had to make sure that it works with the small RNA-seq peculiarities that we have here, and then had to also adjust that within the pipeline so that it works reliably also for protocols that people are commonly using, testing it across different of protocols that we have in the pipeline available, because that's also a bit different to the RNA-seq pipeline. We have a lot of these rather exotic protocols which have very difficult trimming schemas. And if you then also have UMIs added to the game, then it gets even more complicated. So you have to have a lot of test cases to cover that, to make sure that you're not doing something wrongly. So testing actually revealed the different runtime behavior. It was much faster using UmiCollapse. However, the write mode to actually support the protocols in small RNA-seq then proved to be not that trivial, honestly. So we thought this is going to be very easy. We just write a module, you upload that to the nfcore modules repository, you import it to your nfcore, a small RNA-seq pipeline, and then you're done with it. Unfortunately, it wasn't that easy because we had a lot of these weird edge cases that really turned out to be very difficult. We had to fine tune, for example, the regular expressions used for some protocols, had to do some benchmarks and tests. So it turned out to be much more complicated than that. However, we think now the pipeline really has test data for all of the protocols, has properly implemented defaults for some of these regular expressions that you can use for the standard protocols that most people are using and relying on. And we also have recommendations in the documentation now that allow people to understand, okay, this is what I need to do if I want to tune this towards my own protocol, basically. Yeah. Fortunately, that also helped people in the other pipeline in nfcore RNA-seq, because when they, in the end, also implemented UMICollapse into their pipeline, the module was already updated, included the latest version, included a couple of the command line switches that were previously not there, which we just added by doing this for small RNA-seq. So basically, others also had the opportunity to jump on the same train, which really is a good thing to see that happen. I mean, in the end, I can just summarize a little bit, because I picked two main points from the release 2.4.0. Maybe Iron Boxer. In total, there was around 100 issues and PRs addressed in a single release. So you can actually see the changelog on the left side and the README, which is also openly available, of course. So you can also check out the individual ones. A lot of docs were added. We actually fixed a lot of missing points that were not covered previously. We did add the NF tests for all of the individual protocols, for all of the individual points in the pipeline that were not really addressed, and had put quite a lot of focus on the stability. So even all of the local modules that we had previously local were either moved to the nfcore modules repository, thereby also updated, added tests, made sure that they're more generically working also for other use cases, and then re-imported to the pipeline, or we even switched entirely to nfcore modules where this was also possible. So for example, we had a couple of vended bow tie mapping local modules, which we then also completely ditched and replaced with the official nfcore module for bow tie. That's just one example, but there's a couple of other cases where we also did the same thing, basically, thereby also reducing the maintenance burden, because every time a new nfcore template comes out, new standards are actually defined by the community. That meant a lot of maintenance work was necessary for the small RNA-seq maintainers. This is now drastically shortened and drastically eased for everybody. I think the main takeaway I want to also highlight a little bit is such major overhauls are possible, but you need to be aware that you really need, for a medium-sized pipeline like this one, I'm not talking about SAREC or RNA-seq, which are large-scale pipelines, I would say. Even with a small team of 2-3 developers over multiple weeks, you really need up to a couple of months even to actually make that work nicely. A lot, at least myself, I underestimated, for example, how many hours actually went into testing, benchmarking, making sure that certain components do exactly what you want to have, finding proper test data, making sure this ends up in a digestible format into your pipeline test cases so that you can actually make use of them. So these type of things usually take quite a lot of time and are, depending on the pipeline as well, potentially very complicated to do and achieve. Maintenance, however, I think is now much, much easier. So I think also, and I've seen it with the latest template, for example, which is not yet merged into the pipeline at the moment in the dev branch, but it doesn't look as complicated as it was in the past. So it's much, much easier now. And I think that's also due to these major overhauls and changes that we introduced in the pipeline. Yeah, and I think it's also a good thing and to prioritize stability over features sometimes. So I think every pipeline would benefit if at some point people just do a feature freeze basically and just decide on to focus on stability and making everything working more smoothly, improving documentation and everything, rather than implementing new features. Because sometimes I also have the impression, and that's a general kind of thing that you see, people tend to always focus on implementing new features. It's not just always all about new features. I think it's also very well taken if you just look after stability, if you improve documentation, if you improve use cases, if you make sure that everything is tested properly, modules are replaced by central modules and not just local modules, things like that. They may not look as flashy and fancy as implementing a new feature, but I think they're also worthwhile to actually have a focus on. So I would advise people, if you really do something like that from time to time, that you do an intermediate release for your pipeline of choice or help with something like that, then also a focus on these maintenance tasks and stability improvements is really something worthwhile doing. And I think with that, I'm already at the end. So if people have questions at the moment, they can also ask questions now.
Yeah, thank you very much. So I allow now everyone to unmute themselves. So if you have any questions, please go ahead now. Otherwise, I would like to ask you something. So in all your tests, did you see how much of an influence UMIs have on small RNA data? Does it actually make a big difference if you use UMIs?
So in general, I think the quality improved quite a bit. So the protocols with UMIs were actually showing a little bit more. We have some benchmarks for internal data that I can't share, unfortunately, but we have seen that if you do the same analysis and just clip away the data without taking the UMIs into account, you lose a little bit of information. So it's not like changing the picture completely, but it's some, I would say, in the order of 10-15% change in total count numbers that you get more out and accurate counts out than you would have without using UMIs. But that's just an estimate based on the data that we've seen, which also may differ between protocols. So there's a couple of degrees of freedom that you should also be aware of, I think. Yeah.
Yeah. I also think that your focus on stability is very important, specifically for places like ours, which is a core facility. I mean, we would very much look out for these releases that are specifically made for stability, because that's our main priority when
Yeah.
we put something in production. So thank you very much for that.
Welcome. Same for us, actually. So yeah, our main intent and driver was actually to make it more reliable and stable. Because we had a lot of projects coming in with human smrna-seq data, and we wanted to make sure that everything is done properly there. That we can also do it for potential trial analysis, for example, in exploratory settings. But nevertheless, you wanted to make sure that everything is fine. And yeah, that was the main motivator, at least from us here in the team.
Are there any more questions from the audience?
Hi, my name is
Hello.
Bhima. Yeah, I'm also working on one pipeline, and it's like not in the next flow, but we have received one project. This is small RNA data, and they have performed the sequencing, and uh, they want us to, identify the novel reads and the known miRNAs. And I'm trying to use miRDIP2 for that. So I just wanted to know in this pipeline, it's a bit of more biology question, but I just wanted to know about the reference genome that it use. I see that it also uses miR-base and miRDIP2 both, but how does it work when like we don't know what organism we are targeting, or it just like something very related to Viridiplante from miRBase, but exactly
Mhm.
we don't know if what reference genome we should use.
Yeah, it's not so easy to answer that. I think what the pipeline can in general do, and maybe that's more the general take on that, you can select a reference from miRBase, and there's also the possibility to use it from miRGeneDB, I think. You
Okay.
have to make sure that you use the proper reference plus annotation files. If you have them available for whatever you are analyzing, then the pipeline will first attempt mapping against that and annotating against that, and everything that is then, and that's something you can actively turn on and off if you want to. And if then reads are not mapping against that reference, for example, because they don't match exactly what type of organism you're actually looking into, then these will be fed into the novel mRNA detection tooling, so mirdip2 and other tools that are inside. There are plans to extend that functionality. It's not yet there. And that's, as I said, we had to focus really on stability at the moment and not on improving the novel part. But technically, it would work like that, that if you, for example, select something as a reference that is not just what you want to analyze, that then all the unmapped reads end up in the novel miRNA detection part of the pipeline if you turn it on. And then that should hopefully also reveal, for example, novel miRNAs that are maybe even specific to the organism that you're looking for.
Okay.
But that's really depending on your organism. Your mileage may vary. I am not an expert on the novel part. Lorena is actually quite the person to talk to about that. She's also in the chat and also gave the previous talk on that. There were some plans to add that, but for us, the focus at the moment was stability, and also my use cases, for example, are entirely human use cases. So the reference for that is quite well established, I would say. But yeah, you can use it like that. You can map against something else and then feed everything else that is not mapping against, for example, human into the novel mRNA part of the pipeline.
Okay. Yeah, thank you for the answer. Yeah, thank you.
Yeah, sure.
Thank you. Do we have any more questions? No, then I would like to thank Alex for his time and a really good talk. Thank you so much, and all the work, of course, you've done. For anyone who is interested in the previous talk about the small RNA-seq pipeline, I will link that in the bytesize channel on Slack. And if you watch this on YouTube, I will link it in the description below the video. So thank you very much, everyone, and have a great day.
Thank you. Bye, everyone.